So, let's start.
Still
The
trig?
first one, yeah, is using the half angle formula.
Okay.
And it wants to find the sine of 5 pi over 8.
Okay. So the very first thing we want to do is double this angle. Do you know why? I mean,
Because you're putting it over 2, so you need to double it.
Exactly. In other words, we know that the sine of x over 2 is equal to plus or minus the square root, what is it, 1 plus or minus cosine?
Minus cosine.
Minus cosine of x all over 2.
Mm-hmm.
So, it's this part we can figure out. If we double the angle, then x over 2 will equal this. Well, what would x, in other words, if we want x over 2 to equal 5 pi over 8, which we do, then x has to be 10 pi over 8 or 5 pi over 4.
Mm-hmm. And then you always reduce it, right?
Yes. Yeah, it doesn't really matter because all we're going to do is figure out what the cosine of 5 pi over 4 is. In other words, to get our answer, to get what sine of 5 pi over 4 divided by 2 is, it's going to be plus or minus the square root of 1 minus, what's the cosine of 5 pi over 4?
You have to graph it, don't you?
No?
Or no, because it's just pi over 4. So
Convert it, figure out which quadrant it's in.
That would be in the third quadrant.
Okay, and this is a little tricky because we care about the third quadrant to figure out that value. To figure out the sine, we're going to actually try to figure out what quadrant we're in here and use the appropriate plus or minus. So it's two completely different quadrants. In other words, for this, we're in the third quadrant. So what's the cosine, what's the equivalent first quadrant angle for cosine? Or 5 pi over 4?
It's going to be negative root 2 over 2.
Yeah, so let me replace that with negative root 2 over 2. And now, am I going to use the plus or minus sign in front?
Well, you go to the original angle, right?
Right, that one.
And then you do the graphing thing, so it would be in the second quadrant.
Which makes
so
it positive.
Positive, sorry, because it goes...
Sine is what we care about, not cosine anymore. In other words, we evaluate these things completely independent of one another. Here we were looking for what cosine is in the third quadrant. Here we're looking what sine is going to be in the second quadrant, and we know it's positive. So this is our answer. It's not simplified. Do you need to go through that, the algebra of that?
I think I can do that part. Actually, wait, can we, just in case?
All right, let's go through it at least one time.
Yeah.
So it's equal to 1 plus root 2 over 2, all over 2. So operate on the numerator first.
So you'd make that 1 into 2 over 2.
Uh-huh.
And then plus root 2 over 2 over 2. And then you would get 2 plus root 2 over 2 over 2, square root of that. And then you multiply.
So inside the radical we end up with 2 plus root 2 over 4, right?
Mm-hmm.
Okay, let's do that. And now how can we simplify that further?
You have to make it the square root of 2 plus root 2 over 2.
Yep. And there's your answer for the sine of 5 pi pi over 8.
Cool.
Got another one?
Yeah. Got a lot. So these are the find the exact value of an expression. So I have the inverse value of tangent. Actually, that one's easy. Never mind. Okay, let's see if I can find one I don't know how to do. Okay, so the inverse cosine of tangent 3 pi over 4.
Okay. Always remember that when we take the trig function of an angle, we get a number. So I'm going to replace that with a ratio, or a number. And then I'm going to take the inverse cosine of that number. We always take inverse trig functions of numbers to come up with angles. So this is going to equal an angle. Important to realize the way inverses work here. So what's the tan of 3 pi over 4?
You have to make your little graph, don't you?
Well, or figure out what quadrant. You don't really need to make a graph. In other words, what quadrant is that in?
The second quadrant?
So what's its equivalent first quadrant angle?
Pi over 4?
And what's tangent of pi over 4?
Oh, really? It's 1.
Uh-huh. And what's the sine in the second quadrant? On tangent?
Negative 1?
Negative. So that is negative 1. So now I'm taking the inverse cosine of negative 1. Well, where is cosine equal to negative 1?
At 0 degrees?
Remember, this is negative 1 down here.
Yeah.
At 0, it's equal to positive 1.
Oh, wait.
We're looking for where cosine is equal to negative 1. That would be right there. So it's at pi.
Okay. Alright. Oh, yeah, because cosine is x.
What's that? Yeah, in other words, the angle is on the horizontal axis and the value is on the vertical axis. Well, this inverse function, that's the vertical measurement, the negative 1. When you say inverse cosine of negative 1, you're saying where on the y-axis is it equal to negative 1? And it's only one spot, and that's pi. Well, pi, 3 pi. In the unit circle, it's only at pi.
Alright.
Okay, what else?
Then more of those because I don't like them very much. Tangent of the inverse sine of negative 1/2 minus the tangent of the inverse tangent. Wait, no, minus the inverse tangent of, the inverse tangent of 3 over 4. Yeah.
Like that?
Mm-hmm.
Okay. Well, always work from the inside out. So this is going to produce an angle. We're going to then take the tangent of that angle to come up with a number. And this is going to produce an angle. So we're going to end up with a number minus an angle as our answer. You sure I've written this right?
Well, the parentheses are around the 1/2.
Yeah.
Yeah, and then they close off around the tangent.
Okay.
So the whole thing is the inverse sine of 1/2 minus.
So what's the inverse sine of minus 1/2? Where is sine equal to 1/2 in the first quadrant?
At 30 degrees.
Okay, and where is it equal to negative 1/2? Which quadrant?
The third and fourth quadrants.
And one of them is more principal than the other. Your calculator will only give you the fourth quadrant answer.
Oh, why?
Well, because when you're dealing with inverse functions, you can only have one value. when they take the inverse sine, they don't use the whole sine curve. If they did, you'd get something that looked like this. That's not a function. Doesn't pass the vertical line test. So in order to even talk about inverse functions with sine, they restrict the domain from minus pi over 2, fourth quadrant, to pi over 2, first quadrant. So in other words, when you're talking inverse sine, you're talking about that part right there that's been mirrored over the line y equal x to give you the inverse sine function. And it's been arbitrarily decided you could take any 2 points on this curve. In other words, I could go from there to there, also restricting my domain so that it's 1-to-1. In other words, you need to restrict the domain so that it becomes a 1-to-1 function. And they have decided for sine and tangent to go from minus pi over 2 to plus pi over 2. Which means that when you take the inverse sine of a positive number, you're going to get the first quadrant angle. If you take the inverse sine of a negative number, you're going to get the fourth quadrant angle, always. Your calculator will not give you. You have your calculator handy?
No, I do not. That's cool.
Well, if you put in inverse sine of negative 1/2, it will give you the 330-degree answer, but it will not give you the 210-degree answer. Yet, it's a true answer. In other words, the inverse sine of negative 1/2 is also 210. It's just not the primary answer. And when you have problems like this, you always want the primary quadrant, which is the quadrant your calculator is going to give you. If you're talking inverse cosine, then the primary quadrants are 1 and 2. If I said inverse cosine of 1/2, that would be 60 degrees. If I said inverse cosine of minus 1/2, that's going to be 120 degrees. Not also 240. Your calculator won't give you the 240 answer. The 240 answer is correct. If you took the cosine of 240, you'd get negative 1/2. It's just your calculator can only give you one answer. It's not going to give you both. And for cosine, positive is first quadrant, negative is second quadrant. For tangent, for sine and tangent, but for sine in this example, negative numbers end up in the fourth quadrant, positive numbers in the first quadrant. Therefore, 330 is what we want to take the tangent of. So what is the tangent of 330 degrees?
Tangent of 30 is root 3 over 3?
Well, there's 30. Yeah. 1 over root 3, which is root 3 over 3. And positive or negative?
Positive.
Tangent
No.
in the we're in the fourth quadrant, remember.
Fourth, it's negative.
Yeah.
I did third. I don't know.
Negative root 3 over 3. And see, it actually makes a difference. This whole concept of the principal value as opposed to the other quadrant answer. If we were allowed to give the second quadrant answer, which is 240, then you're taking the tangent of 240 and you're going to get a positive number. So it's a significant consideration is when you do inverse trig functions to give their singular quadrant, not two quadrants. Okay, so this is the answer to the left part of this thing, minus the inverse tan of 3/4. If I look at a 3, 4, 5 triangle, they want that angle right there.
So opposite over adjacent, so 3 over 4?
Well, the tangent of theta would be 3 over 4, but the inverse tangent of 3 over 4 has to be theta. In other words, by definition, if tangent of theta is 3 over 4, then the inverse tangent of 3 over 4 is theta. Well, most people don't know what that angle is. I happen to know it's 37 and change, 37 degrees and change. So in place of this, now this is a bit of a puzzling answer because we have a number minus an angle. Now, I could make this angle in radians, I suppose. Not sure that really helps anything.
I don't know. I'll write it down and then I'll ask myself.
Yeah, write it down like this, and your calculator could also give you that in radians. In other words, if you put in inverse tangent of 3/4, it'll give you the radian answer, and you could put that down also. But feels like I miswrote this because usually you end up with a number minus a number or an angle minus an angle. It's rare that you end up with a number minus an angle as an answer. Okay, what else you got?
Find the exact value of each expression.
Okay.
And this one says cosine 100 times cosine 20 minus sine 100 times sine 20.
And let me guess, you're not allowed to use your calculator.
Of course not.
Of course not. Because it
That would
wouldn't be a problem if it was a calculator problem. So,
Yeah.
what does this look like?
That looks like
Half angle, double angle, sum and difference?
sum and difference.
Sum and difference.
Cosine?
So this is the sum and difference for cosine or sine?
Sum and difference for cosine.
Right. If I have the cosine of A plus or minus B, it's equal to the cosine of A, cosine of B, opposite minus or plus the sine of A, sine of B. Well, what we are looking at is this over here. So let's put it back together. What is this going to be? We got a minus sign there, so it must be the plus.
Yeah.
And the two angles have to be 120.
Yep.
So what we're really looking for is the cosine of 120. And that we can do without a calculator.
Yep, because you go 60 degrees, right?
Uh-huh.
It's the ish angle, and then the cosine of 60 degrees is 1 over 2, but then it's negative because you're in the second quadrant.
Okay, you got it.
Sweet. Well, that's not even something I have to do. Okay. So then I have some more exact values, but the kind where you have to graph two things.
Okay.
So using the sign of A is equal to negative 4 over 5, and the cosine of B is equal to negative 5 over 13. You have to find a bunch of stuff.
So we need to find A and B?
No, you need to find the sign of A minus B.
Okay. What's the equation for the sum and difference for sine? The easy way to memorize it And there's a reason they give you the cosine one first in the book. It might seem a little odd that you get cosine before you get sine, right?
Mm-hmm.
Well, cosine is pretty easy to remember. It's got two cosines, opposite, and two sines. Piece of cake. Well, sine has got sine, cosine, same sign, sine, cosine. In other words, they both have two sines and two cosines in them. Now, the only question is does the A go there and the B go there? Yes. And then the B goes there and the A goes there. So, I can figure out what the sine of A minus B is by solving that. Well, they give us the sine of A, that's negative 4/5. They give us the cosine of B, that's negative 5/13. What's the sine of B? If the cosine of B is negative 5/13, we don't have to graph it, we want to draw a triangle. This is B.
So
how can I dimension that triangle?
So it would be a 3, 4, 5?
No, it would be a 5,
It would be 5, 12, 13.
That's the part we can dimension. And now I use the Pythagorean theorem to come up with that side as 12. It's a 5, 12, 13 triangle also.
Yeah.
So the sine of B must be 12/13.
Okay.
Now, is it positive or negative?
It would be negative. No, it would be positive. No, I'm looking at the wrong thing. It would be negative. Right?
Well,
It would be in the
it's not
second
clear.
quadrant.
It's not clear to me.
For me, I forgot to give you something. For that triangle, it says that it's between 2 pi and pi on a graph.
Oh, between 2 pi and pi. That would be third or fourth quadrant.
No, it would be the second quadrant.
It's between
pi over 2. Sorry, pi over 2
and pi. Okay.
Yeah.
So
Sorry.
it's second quadrant. For angle A or angle B or both?
For angle B, and then for angle A, it's between 3 pi over 2 and 2 pi.
So there's the quadrants. Okay? So if B is in the second quadrant, then the sine of B is going to be positive. Positive 12/13. Right?
Okay.
In other words, they're telling us that B is in the second quadrant. That's why its cosine is negative. And therefore, the sine of B has to be positive if B is in the second quadrant. What's the cosine of A? Let's draw another triangle, because these are two completely different triangles.
Yes.
Well, A is this angle here, and it's also a 3, 4, 5. So what would the cosine of A be?
3 over 5.
Positive or negative?
Negative.
A is in
Positive?
the fourth quadrant, right?
Yeah.
So cosine has to be positive in the fourth quadrant. So cosine would be 3/5. Now you have everything you need. And in fact, it's not that hard of math because it becomes 20/65 minus 36/65. So you have minus 16/65 is your answer.
Okay. That would be enough. Do we have time for one more, do you think?
Sure, sure.
Okay. So it's the same thing, but the double angle sine of A, or sine 2A.
Okay, what's the general formula for the sine of 2A?
It
2
is
sine cosine.
sine times cosine.
Yeah, and these would have to both be A. So if you see this, then that's the same as the sine of 2A. Okay, so what's the problem?
Just using that same triangle that we had. The negative 4 over 5.
Do they give us any values for anything?
Well, yeah.
Oh, I see. In other words, the sine of A is still equal to negative
4 over
5/13. So negative, what was it, 4/5? And the cosine of A, that's what we figured out, right?
Yeah.
Cosine of A was 3/5 positive. Because A is in the second, no, A is in the fourth quadrant.
Fourth quadrant, yeah.
That's why its sine is negative and its cosine is positive. So if you want the sine of 2A, then it's going to be 2 times negative 4/5 times 3/5, which is 24/5 negative.
Yeah.
And that is the sine of 2A. Now, excuse me. I knew it couldn't be over 1. I had to make a mistake somewhere. In other words, you can never have the sine of an angle be greater than 1 or less than -1. Same with cosine. So when I came up with this answer, I had serious problems. That was less than -1. That's because I forgot to multiply the 5s. So the sine of 2A is that. Now, A is in the fourth quadrant, right?
Yes.
So 2 times A would probably put it in the second quadrant. Almost certainly. If you had a 300-degree angle and you double it, that's 600. Actually, that puts it in the third, 240. But sine is still negative in the third.
Oh, wait, you have to double it?
Yeah. In other words, if A was a fourth quadrant angle, which we know it to be, well, 2A, we would have to double it then. In other words, let's say A was 300 degrees. Well, what's the sine of 600 degrees? It's going to be -24/5, but it's also going to be the sine of 240, same as 600. And the sine of 240 is third quadrant, negative. So we have our sine proper, if the angle was 300. If the angle was, I guess it always puts it in the third quadrant when you double it. When you double a fourth quadrant angle, yeah, it puts it in the third quadrant always.
Okay.
No, it could be in the fourth quadrant even. In other words, if my angle was 330 and I doubled it, I would be at 660. That's in the fourth quadrant. Interesting. And then the sine, it would still be negative. The sine is negative in the third and fourth quadrant. And if we take a fourth quadrant angle and double it, it has to end up in either the third or fourth quadrant. And sine is negative in both. So it makes perfect sense that the sine of 2A would be negative 24/25.
Alright. Cool.
Okay? Take care of it?
Yep.
Alrighty. So I hear you're off to Massachusetts next week.
Yep.
Well, I hope it's warmer there than it is here, but probably not likely. I'm glad you're going next week and not this week. You wouldn't be able to get around. They got people stranded in New York right now on the highways.
Massachusetts. Oh, it's always
Highways that had so much snow so quickly that all the highways are full of cars. But hopefully by next week you'll have a little bit better weather. All right. I will talk to you in 2 weeks then, Sarah.
All right, perfect.
Good luck on your quiz tomorrow.
All right, thanks.
Bye-bye.